Welcome back, student. In my today's lecture, I am going to explain certain short examples on laws of chemical combination. All the laws of chemical combination are already covered in my previous lecture. The link for it given in the description box. So one by one, I am going to cover the salt example. The first salt example is carbon and oxygen are known to form two compounds. Carbon content in one of these compound is 42.9%, while in other compound it is 27.3%. So by observing this data, what we can conclude that which law this data follows. The first option is law of multiple proportion, second option is law of definite proportion, third option is law of reciprocal proportion, and fourth option is law of gaseous volume. So whenever you get certain sum, as it is given that it is forming two compound, means you have to construct a table which indicate the compound 1 and compound 2. Hope this table is visible to you. So I am going to make it as a zoom view for your better understanding. So this is a zoom view for you. So compound 1, the mass of carbon in compound 1 is 42.9%. So you can find out what is the percent of oxygen in compound 1. That you can do by normal subtraction. So 100 minus 42.9, you will get 57.1%. Similarly over here, it is given as mass of carbon in compound 2 is 27.3%. So you can subtract it from 100, you will get mass of oxygen in compound 2 as a 72.7%. Now these are the values which are given in a percentage. You can even consider them as in a gram. This will come as a 42.9 gram and this will come as a 57.1 gram, and so is applicable for these values. So now we have to make one thing as a constant, either a carbon or as a oxygen. So what we are considering, that mass of carbon which combines with 1 gram of oxygen. So instead of considering 57.1 gram, if I say if it is just 1 gram, then what will be this answer? So if 57.1 gram is combining with 42.9 gram, then 1 gram will combine with how much? So by cross multiplication, you will get the answer as a 0.75 gram. Similarly over here, as we know 72.7 gram is reacting with 27.3 gram, then how much of the oxygen, how much of the carbon will react with the 1 gram of oxygen? So by cross multiplication, you will get the answer as a 0.375 gram. So we made one of the component as a constant, that is oxygen as a 1 gram, and we got how much carbon will be required in case number 1 and how much carbon will be required in case number 2. So the ratio of the carbon combining with the fixed mass of oxygen is coming as 0.75 is to 0.375. So that ratio is coming as 1:3. So from this ratio and our discussion, as we know that as per the law, that if two elements combine in different ways to form two substances, the mass ratio are small and whole number multiple of each other. This law is a law of multiple proportion. So here also there are two elements which are combining in different way. That is, carbon is combining in different way with the oxygen. The mass ratio are small and whole number multiple of each other. So here we can check that mass ratio is a simple whole number ratio, that is 1:3. Next is 12 gram of carbon combines with 64 gram of sulfur to form carbon disulfide. Carbon also combine with 32 gram of oxygen to form carbon dioxide. Third case is 10 gram of the sulfur combines with 10 gram of oxygen to form sulfur trioxide. So if you see over here, now it is much complicated. So you require more attention. So carbon and sulfur are combining in case number 1. Carbon and oxygen are combining in case number 2, while in case number 3, sulfur and oxygen are combining. So whenever you get certain data, now as per our laws of chemical combination, which law these data justify? The first option is law of multiple proportion, second option is law of definite proportion, third option is law of reciprocal proportion, and fourth option is law of gaseous volume. So whenever you get certain question where three combinations are given, you have to frame in this way. As in case number 1, CS2, C is equals to 12 gram while S is equals to 64 gram. In case number 2, that is CO2, carbon is 12 gram and oxygen is 32 gram. In case number 3, SO2, sulfur is 10 gram and oxygen is 10 gram. So as you see, the carbon in case number 1 and case number 2 is a fixed value. So the ratio of sulfur is to oxygen is coming as 1:2. And over here that ratio is 1:1. So as per the law of reciprocal proportion, when there is a combination of three different elements, if we keep the mass of the one element as a constant and if we take the ratio of the masses of other two, that should come either equals to the simple whole number ratio or as a 1, as a multiple. So this question justifies the law of reciprocal proportion. Now this is a third question for you. That is 9.8 gram of sulfuric acid combines with a barium chloride. The amount of barium chloride is 4.95 gram to give 12 gram of barium sulfate and 2.75 gram of hydrogen chloride. So looking at this data, what is our assumption that which law this data justify? First is law of multiple proportion, second is law of definite proportion, third is law of reciprocal proportion, and fourth is law of conservation of mass. So over here, first we have to construct a reaction because it is indicated that sulfuric acid is combining with barium chloride. So you can say that here is a sulfuric acid which is combining with a barium chloride. So as sulfuric acid is 9.8 gram and barium chloride is 4.92 gram. These two reactant gives a product, and in product you are getting barium sulfate and hydrogen chloride. The amount of barium sulfate is 12 gram while hydrogen chloride is 2.75 gram. So if you sum up the masses of the reactant and the product, you will get the answer which is equal. It will come as 14.75 gram. So as per the law of conservation of mass, during the course of reaction, there is mass which does not form or create, does not change, it remains the constant. So this question justifies the law of conservation of mass. The next is ammonia contains 82.35% of nitrogen. So in ammonia, as you recollect, it is NH3, so it containing a nitrogen that is 82.35%, while the hydrogen in ammonia is 17.65%. Now second is water. So it contains 80.90% of oxygen and 11.10% of hydrogen. Now third case is nitrogen trioxide, that is nitrogen and oxygen combination, where the percent of oxygen is 63.15% and percent of nitrogen is 36.85. So these data where there are three different compounds are given, we have to find out that which law it justifies. So the first option is law of definite proportion, second option is law of reciprocal proportion, third option is law of conservation of mass, and fourth is law of multiple proportion. So as you get certain question where there are three different compounds are given, then you have to construct it in a way that percent of nitrogen in compound 1 is 82.35% while the percent of hydrogen is 17.65%. So we can find out that how much amount of nitrogen may combine with the 1 part or 1 gram of the hydrogen. So by simple cross multiplication, you will get the answer as the amount of nitrogen which combines with 1 part of hydrogen as a 4.67. Similarly, for the second case of the water, the percent of hydrogen is 11.10% and percent of oxygen is 88.90%. Here again you can find out the amount of oxygen that combines with the 1 part of hydrogen. So by again a cross multiplication, 88.90 into 1 divided by 11.10, you will get the answer as a 8.01 as the amount of oxygen. So if you find out the ratio of nitrogen and oxygen in these two compounds, you will get that ratio same as the ratio of nitrogen and oxygen present in the third compound, that is nitrogen trioxide. So it is given as percent of nitrogen in nitrogen trioxide is 63.15 and percent of oxygen in nitrogen trioxide is 36.85. So when we take the ratio, the answer is come as 1:1.71, which is the same ratio as the amount of nitrogen present in a ammonia and the amount of oxygen present in a water. So again, this question justifies the law of reciprocal proportion. It is similar to the previous example of carbon dioxide, carbon disulfide and sulfur dioxide, which we have covered. So next question for you is, a sample of magnesium carbonate is 50% pure. On heating, 4 gram of magnesium oxide and 4.4 gram of carbon dioxide are formed. So again here there is a chemical reaction. So first we have to construct that reaction. We have to find out the amount of MgCO3 being taken for this particular reaction. See, options available for you are, the first option is 8.4 gram, second is 16.8 gram, third option is 33.6 gram, and the last option is 3.2 gram. So for certain question, as you follow the law of conservation of mass, we know that MgCO3 is giving you MgO and CO2. So whenever certain reactions are there, it always follow the law of conservation of mass for sure. So the molecular weight of MgCO3 is 84 gram. It will give you MgO, the molecular weight of MgO is 40 gram, and it will give you the carbon dioxide, and molecular weight of carbon dioxide is 44 gram. So without looking at the question, if you just write the reaction that MgCO3 is converting into MgO and CO2, so 1 mole of MgCO3 will come as 84 gram, which gives you 1 mole of MgO, that is 40 gram, and 1 mole of carbon dioxide, that is 44 gram, as per the law of conservation of mass. But in our example, it is been said that magnesium oxide is forming just as a 4 gram. So if you make that 40 gram as a 4 gram, means you are dividing by a factor of 10. Similarly over here, if we divide 44 by 10, it will come as a 4.4 gram. So you can say that as we are dividing on a product side, we can simply divide on reactant side, and we will get that this should be 8.4 gram, because 8.4 gram is equals to 4 gram plus 4.4 gram. So this is how you may feel that answer is 8.4 gram. But just look at, we said that it is just a 50% pure. If it is 100% pure, that is, if it is 100% you can say magnesium carbonate, then only it will give you 4 gram of this and 4.4 gram of this. But condition given is it is just 50% pure. So if you are taking a full 84 gram, actually it is working like 49 gram only. So if you take it as a 168 gram, then it may behave like a 84 gram. So we want that it should be 8.4 gram. So we have to take it as a 16.8 gram, because it is just a 50% pure. So the answer for this question will come as a 16.8 gram. So this is all about my today's video. In upcoming video, I will come up with more such solved examples, which will definitely help you for your boards exam, for your NEET and JEE exam. Thank you. I request you that you subscribe my channel, like it and share it. Thank you once again.